Hello everybody. It's time to talk about unit testing, and we'll be talking about the new testing feature of Google Tag Manager custom templates. And it's a feature I'm particularly excited about because it kind of introduces a paradigm that's very common in the software development world and inserts it into Google Tag Manager, which is, I think, for many still predominantly a marketing tool or marketer tool. So with tests, you are introducing stability and predictability to the code you introduce to custom templates. So if you're a custom template author like myself and you want to distribute your custom templates to users through Google Tag Manager's own gallery, for example, writing tests for those templates is almost the responsible thing to do because you are promising your users that the test will behave in a predictable way whenever you add updates to it. So with this video, I'll walk you through how to write a simple variable test and then a more complicated tag template test. And hopefully you'll get the confidence to and the inspiration to write tests for all your templates and kind of adopt this kind of test-driven development mindset, because it really helps you structure your code in a more atomic, more stable way, which is more resilient to changes you might introduce in the future. So I hope you enjoy the video, and let's jump right into it. As always, this video is accompanied by an article on my blog. This time it's a GTM tips article where I walk through the test samples that we're going to be building in this video as well. So the article is basically just a rewrite of what we're doing on the video. If you prefer to read things rather than watch them, then this article will be useful for you. I'll add the link in the video notes. There's also the guide for tests on my blog, which goes through all the parts and aspects of writing a test, including mocking and assertions and stuff like that, and the test setup. We'll go over most of these things in this walkthrough, but it's still a good guide to take a look at, just to refresh on why write these unit tests in the first place. And then there's of course the official developer documentation for Google Tag Manager, which is in excellent shape and has the new test APIs listed in the reference section. So here are the APIs, the 5 APIs that currently exist that we'll be using to build our tests and make sure our template code runs predictably. There's also a guide under the templates for tests, which is a useful thing to check out as well. But like I said, we'll be focusing on the reference. So what we'll be building today are two tests. We'll be building one variable test and one tag test, and we'll start with the variable. So in the gallery, there's a variable of mine called string from array of objects, and we'll just install this to the workspace. And the purpose of this template is to take an array as the input, an array of objects more specifically. So it would be an array that has objects, one or more objects within with properties, and then you indicate which property you want to take from that object or those objects to concatenate into a string. So in this example, for example, there's an array of objects which each have an ID and a name property, and you specify that you want to create a string of all the IDs. So you would put the input array variable here, then you would specify ID as the object property, and it would output a string that looks like this. So this is the kind of thing that we'll be working with. And I'll just show you an example. I'll create the test array just so that you'll see how this thing works. So I'll just use a simple custom JavaScript variable to return an array of objects. So it will look like this: ID 123, name something, and then we'll add the other ID 234, name something else, something like that. Let's just keep things clear and just put a name there and save it. So now if we put ID as the object property and the array is the input, then we can run the code to see what it actually returns. So it returns a string where the IDs are concatenated. If you change this to name, it will return something and something else, because that's the value of the name property in this array. So this is a useful variable to use, for example, if you're working with the Facebook pixel that might require a string of IDs in the content IDs property. So you can create this from the enhanced e-commerce data layer, for example. But what we want to do is we want to write some unit tests to make sure that this thing works as predicted. So there are a couple of things that are happening here. First of all, if the input is not an array, let's see what happens. The variable returns undefined. So that's one thing to test. If the input is not an array, we want it to return undefined. If it's an array of objects, but it doesn't have a single property with the thing you specify in the field, so let's put something like description here. Now the array that I created doesn't have the key description, so let's see what happens. So it returns an empty string. And I don't have an example for you here, but if it's an array of something else than objects, so just an array of numbers or array of strings, it would also return an empty string. And then if it's a valid input, then it returns the concatenated string. So there are basically 4 test cases: returning undefined, returning an empty string if there is no properties, returning an empty string if the array does not have any objects, and finally returning a valid value, an expected value if the input is valid. So to do tests, you check out the tests tab here. There's a setup portion here, and this is what you can use to establish variables or parameters that apply to every single test. Well, the tests that we'll be writing for this variable template are pretty easy, so we can actually ignore the setup for this. We'll be using it in the tag section more. If you now just run tests, you'll get the error that no tests have been defined. So let's write a test, and let's make the first test about return undefined if input not array. You can actually write proper English if you want. This is just out of force of habit for me. So you can see that the test is pre-populated by this code. So here we are invoking the run code API. So the run code API is described here. The run code API basically runs the variable template code, and it takes as an argument an object where each property corresponds to user input. And I'll show you in a bit just what I mean. And then the variable result is asserted. So tests always use assertions to check what was the result of the test. So you're basically establishing whether or not the test was a success. And in this case, the assertion is, it reads almost like English. So assert that the variable result is not equal to undefined. So when the run code method has no input or no argument, it will use the values added to the template preview. But this isn't how you run unit test. You basically have to give a mock object to test different parts of the test. You can't expect a user to always add some input to the template preview to make sure that things work. So the first thing we need to test, let's just put an empty object. And this basically means that the user hasn't added anything into any one of these fields. All these fields are empty. So when we try to run the test now, it actually fails the test because the variable returns undefined. And here the assertion was that assert that the variable result is not equal to undefined. So this was actually a failed test. And now we have to figure out how to run this test so that it gets an expected result, which is that we expect the result to actually be undefined. So what we'll do is we'll create a mock object first. So the mock data object will be what we use to specify that for this particular test, what was the user input. And now we need to check out what the fields names are. So we have a help text field. You can ignore that because it's just the help text. You have an input array field, which is the value that the user has to the input array. You have the key to concatenate property, which is which key to actually concatenate the string with. And then you have the delimiter. So let's add those into our mock object. We have, input array. We have key to concatenate, and we have delimiter. And then let's add some values. So in this case, we need the input to not be an array. So let's put anything here, not an array. Now it's a string. We'll set the key to concatenate to the default value of a comma. Let's put that to ID, for example, and the delimiter to the default value of a comma. So what we are doing here is this would be a mock object. So in this case, the input array JS example would actually return a string, not an array. The key to concatenate, so the object property is ID, and the delimiter is a comma. So the test is run as if the user had added these values into the fields. So then we'll run the code. We'll actually use a const here. There's no reason to have it as a let. And we pass the mock data object to run code. So now the variable template is run with these inputs. And then we need to check out the assertion. So currently this assertion would fail because the result should be undefined. So let's see if that happens. So indeed, the variable returns undefined, so the assertion fails. This test is not a good test because it doesn't actually succeed. So we can actually run is equal to undefined, and this would work. So if we now run the test is a success because we expect it to return undefined. But there's an even easier assertion to use. It's just is undefined. So it's the same thing as is equal to undefined, but this is perhaps a bit more readable. So this is a unit test. Now, whenever I make changes to this template, I need to run this test to make sure that still, even after those changes, if the user inputs anything other than an array, the variable template code would return undefined. So this is what this test is built for. It tests whether the variable returns undefined, because that's what I expect it to do. If this test fails, then there's something changed in the variable template code that actually doesn't return undefined if there's an invalid input. And then I know I have to fix this. I've broken the template code. So this is why we use unit tests. So now we've checked out the first scenario. Return undefined if input is not an array. Let's add the second one. Return empty string if array has no object. So if the input is an array, but it has no object. So let's just copy the code. And now we need to change the mock data a bit. Now it has to be an array, but it can't have any objects. So let's do something like 1, 2, 3, 4, 5. It's an array of, it's an array of 5 numbers. Not one of these is a plain object or an object literal. So this variable should now return an empty string. So again, we do the run code against the mock data. And now this time we assert that the variable result is equal to empty string. So now this test should pass because it returns an empty string. However, to make this a bit more easy to maintain and read, let's create the expected value into a variable as well. So the expected value is an empty string, and then we just use it here. So this way you eliminate typos and possible mistakes, especially if you have to use the expected value in multiple places. It's just a good design pattern to fall into. So now we've built a test where the input is an array, we run the code with that input, and then we assert that the variable actually returns an empty string. So the empty string is the expected value. If this test failed, it means that when the input is an array, the variable does not return an empty string, and I need to fix it because that would again be a broken implementation. So the next test we do is return empty string if array objects don't have the, oh, this is absolutely horrible descriptions of tests, but please bear with me, and you can be a much better you can write better descriptions once you start writing tests, and please do. So this time we have an array of objects, but they don't have the key to concatenate. So let's do something like name Simo, and the second one is name Charles. So now we have an array of objects, but we don't have the key that's expected. We only have the key name in both the objects. And again, the expected value is an empty string. So call run code with the mock data, and then we assert that the variable return result is equal to expected. So let's see what happens. Again, we're successful, so the variable value is an empty string. We've now tested this scenario as well. And finally, we'll do one more test, which is return concatenated, that's not concatenated string if if input is valid. You want the test name to actually describe what the test does. So these are not very good descriptions, but that's okay. So this time let's do a proper input. So we have objects with the key ID with value Simo and Charles. So we expect this to actually return a string with Simo, Charles once we run the code against the mock data. So let's see what happens when we run this test. So here we go. We have executed this test with success. And once you've written all your tests, you can actually run all of them, and the console will show you that yes, all of them were successful. So now we've written 4 tests, and let's talk about code coverage a little. We need to check that all the code coverage is, there's some redundancies here. I actually need to update this template. So ignore the beginning, but here we have a helper method, which is actually there's an easier way to write this. We can actually use const get type API now. So we can actually fix this template while we're at it. And then we do if get type input array is not array, like this. So the get type API is actually pretty nice because it makes it trivial to check for type. So let's just improve this a little. We've actually fixed this template now. So let's talk about coverage. Let's run the tests again just to make sure that my change didn't break anything. Yes, all the tests still work. So just an example, if I now change this to a strict equal, let's see what happens to the tests now. I made a change to the template code. And now you can see that the tests actually fail because it gives me something like map is not a function, and the expected and actual values are different. Because it always returns an empty array now, because the at least for the latter 2 tests. So this is this completely breaks the template. All my tests fail just by changing a single symbol. So this is a great way to make sure that your variable is working in a predictable way. But about coverage, so when we talk about coverage, we talk about all the lines of code that have been covered by the test. And variable assignments like these are automatically covered as soon as you use any one of these in the test. So because we are mocking these variables, these lines will always be run in the variable. They're not part of a branch, so they are tested implicitly. But then in this case, for example, this return statement is only covered if you have a test where the input array is not an array. If you didn't have a test for that, this return statement would not be covered, so it would not be part of the code coverage. With this return statement, you are basically, whenever this return statement is reached, all these commands are actually covered because they are chained together, unless there's a syntax error and the template fails at one of these, then the rest would not be covered. So by writing these 4 tests, we're checking the one single branch that we have, which is an invalid, so the input is not an array. We are actually testing this. So we should have 100% coverage with these tests. So this is how you build a simple variable test. And this is actually a very simple way to write a test, but we'll get a bit more difficult. It will get a bit more difficult once we hit the tag template, which we'll do next. Just as a reminder, remember to check out the test API's descriptions in the reference guide, because these are really useful to understand all the different types of tests you can run. So you can find the assertions under the matchers. So see, these are the different assertions currently supported, and I'm sure that we'll have more in the future. Just remember to check these out periodically to know what's going on. So let's work with our tag template next. It's a bit different than a variable template. When a variable template is tested, you basically test the variable result, which is super easy. You can always have the final say that the test is a success if the variable has a predictable result. But tag templates don't return anything. They run different APIs and then they signal completion. So we can always test did the tag signal completion, but this doesn't mean that the tag is actually working. So let's look for our template. we'll be using the user distributor template here. So we'll add that to the workspace, and we'll work with that. So we'll run some tests against this. So let's talk a little about this template. The way it works is that you can specify two different types of distributions. If you use a single distribution, you say a probability of being included between 1 and 100. So this is a percentage. So let's say 30. And if you add 30 here, then a random number generator produces a number between 1 and 100. And if it's 30 or below, a cookie will be written for you. And the cookie settings are here. So the cookie GTM group would get the value true if the random number is equal to or below this probability, which basically means that you can use this for sampling. You can choose to sample 30% of your visitors by writing a cookie if they are included in that sample. And then you can use this cookie to prevent tags from firing, for example. If it's above 30, then the cookie value will be false. And the key thing is that the cookie is always set. So this user distributor is only run if the cookie isn't set. So it's only run for users who haven't already been distributed. The multi is a bit different. So here you can specify different groups. Variation 1, distribution 25, variation 2, distribution 25, for example. So in this case, you're saying that if the random number is between 1 and 25, assign the cookie value to variation 1. If the distribution is between 26 and 50, which is the second 25% cohort, then the value would be variation 2. And anything over 50, the cookie would not be set. So if you have variations up to 100, like this, let's put 50 here, then this would mean that every single one of your users should be included in one of these groups, because the random number will always fall in one of these distributions. But if the total is below 100, then you will have 1% chance in this case, for example, that the user will not be added to a cookie. So the things to test here are if the cookie has already been set, do nothing. That's the first thing we need to test. If the cookie has not been set, we need to test that when the random number generator is run, and the number is equal to or less than 30, then a cookie is set with the value true. That's our second test. Our third test would be that if the single distribution is selected and the random number is larger than 30, or whatever we have in the probability, the cookie value should be false. And the fourth thing we need to test is that these cookie parameters are written correctly, because that's really important for the code itself. So, and then to test the multiple distributions thing, it's pretty similar. We need to test that if we'll use two variations for this. If the random number is equal to or below the threshold for variation 1, we need the value to be variation 1. And if the value is equal to or below the threshold for variation 2 accumulated, so 50 in this case, the value should be variation 2. And if it's over the combined accumulated probability here, the cookie should not be set. And the last test would be to test whether this cookie was set with the right parameters, because that's again really important. So if we look at the code itself, we have a bunch of APIs. We're setting a cookie, we're reading a cookie, we're generating a random number, we're turning something into an integer. We're not actually using log to console, so we can remove that. And here we have a bunch of branching things to test. So if read cookie length is 0, so the cookie has not been set, this is the first branch to test. So our first test will be to check that the cookie has not been set, because then this block will be ignored and the data.gtm on success will be simply run. So let's start with the test, and this gets a bit more complicated than the previous example. And because of this, we'll actually use a setup here. We'll be using the same type of input, almost the same type of input for single and multiple tests throughout. So we can use the setup to just create the mock objects. So let's create a single mock data object. And here we'll need to set the input for distribution type to single. So split type is the input and the value should be single. So let's put split type single. Then as the value of probability of being included, let's use 50, just to get a A/B test, like a 50-50 split. and this would be single percent. So single percent should be 50, like this. There are no multiple percent being written because that is only enabled if multiple is chosen. And then for cookie settings, this is going to be a cookie name is going to be GTM group. Like this. Let's see what else here is. Cookie domain would be auto. And cookie expires in 365 days. So this is our mock objects that we'll use for all our single mocks. And then for our multi-tests, we'll do a similar mock object. Let's just copy these actually. Oops. Like this, split type is multi. The cookie name, domain, and expires should be the same, but then we have the multi%, and because it's actually a simple table field, it becomes an array of objects where each object corresponds with one row. So let's see what the field names are. So we have value and probability are the names of the fields. So we'll do multi% value, probability. So let's do variation 1, 33% probability, and variation 2, 33%, and nothing else. So we have a 66% chance of being included in a test or in a group, and 33% chance of not getting the cookie written at all. So we've got our test set up. We have no test set up, so no tests have been defined. So let's get to work. Our first test is if the cookie is not set, we just signal completion. So let's start checking out how we write tests for tag templates. So let's create a new test, and with tags you can see that there's a run code method called here, and then every single test will by default check that the GTM on success was called. You can of course check for GTM on failure as well if you're specifically looking for a failed test. And if you're doing like really atomic testing, you might not even be interested in GTM on success. You just want to check parts of the test. But this is a good way to make sure that the tag actually works. It doesn't really make sense to measure just atomic parts of the test, but a good like end-to-end run is always useful to make. So the difference to the variable template is that first of all, we're not actually assigning run code to any variable because the template doesn't actually return anything. And instead of assert that, so we're not asserting a result, we're asserting that an API was called. So in this case, the test is successful if the GTM on success API was called. And the GTM on success API is basically data.gtm on success. And every single template should have that at some point. So to test, do nothing if cookie exists. We need to have a situation where the get cookie values API is called. So the get cookie values, the get cookie values API is called. It fetches the cookie name, which is GTM group, and the cookie has to be set. Now consider the unit test. We need a cookie to be set, but to have a unit test against real cookies would be really inefficient and can get actually also a bit dangerous because you are adding stuff to the global scope in your unit test. So this is again where mocking is useful. So what we need to do is we need to tell the test that whenever the get cookie values is run, it should use a mock API instead and not the actual API. And this way you protect your test from polluting the global space. So we use it like this, mock, and then the API name, get cookie values. Get cookie values returns an array of all the values matching the cookie name that was given. So if we want the cookie to exist, all we have to do is return an array with anything in it, because the code tests the code checks, does the get cookie values have a length of 0? If it's anything over 0, the cookie exists and the code will skip the whole distribution thing. So we'll just return an array with a single value. It can be 1, 2, 3, true, empty string, populated string, whatever, as long as there's something in the array. Now the array's length is more than 0. So this way, whenever the getCookieValues API is called, it actually returns true as an array. It doesn't actually check any cookies. So then run code is run, and now we pass the mock object, so we pass the single mock. And this is established in the setup. So we don't have to create the variable in the test itself, we can use the variable created in the setup. So we're running the test, we're running the template with this type of input, but this is all irrelevant because the getCookieValues will return a positive value, so none of the code is actually run. And then we can assert that the GTM onSuccess API was called. So let's see what happens. So the test was a success because the GTM onSuccess API was called. But this is an okay way to run it, but we want to get good coverage. So the way you test a tag template is to make sure that all these different APIs have been called. So we need to make sure that generateRandom was called, because it's outside the if block. It should be called and whenever the tag is run. So generateRandom has to be called. ReadCookie has to be called. So getCookieValues has to be called because it's actually the part of the if block. But then setCookie, makeInteger would not be called. So setCookie and makeInteger were not called because they were within the if block that is skipped because the cookie exists. So the way you would establish this test would be something like assert API, generateRandom, that's the API name, was called. Assert API, getCookieValues was called. Assert API, let's check if it's setCookie or something. It's setCookie. Assert API setCookie was not called because it was within the if block. Assert API makeInteger was not called. So we're testing the API. We want predictable API invocations. So as long as these all are true, then the test is a success. So let's see what happens. So now the test is successful because nothing was done. The generateRandom and getCookieValues were called, but then the whole if block of setting the distribution cookie was not called, and the makeInteger was not called either because that's part of the multi-distribution anyway. And finally, GTM onSuccess was called. So this is how we ensure that a tag template works. We check that the APIs have been called. So let's do the next test. The next test is set single cookie to true when in distribution. So we are generating a random number this time that has to be equal to or below 50. And if it is equal to or below 50, then a cookie with the name GTM group is written and the value should be true. So let's see how we'd approach this problem. First of all, we need to do some mocking again. We now need to make sure that the getCookieValues returns an empty array because there must not be a cookie with the name GTM group. So let's mock that. getCookieValues, and this time empty array. So this would indicate that the cookie has not been set. It would be a pretty useless test if we actually used a real random number, because then it wouldn't have a predictive value. The test would fail 50% of the time. So we can actually mock generateRandom as well to be 50. So we're generating a number that is exactly the edge case. So 1 to 50, so equal to or below 50. So we're actually generating 50 because we want to test the very edge case. The code is run with mock single. And again, let's see what happens if we just have this. It's single mock. So let's see what happens. Obviously this test would be a success, but this is again a really useless test because we're not testing actually anything significant. Let's first make sure that we have our API calls. So generateRandom is called, getCookieValues is called, setCookie is called, make integer is not called because that's again part of the multi-distribution. So let's add those here. Assert API. Let's just copy them from the previous one, save some time. So take all of these. And this time setCookie was called. So let's see what happens now. So the test was a success because setCookie was called this time because the cookie itself did not exist. But we want this. We want to know if the setCookie was called with the value true. So this is where it gets a bit difficult. There is no was called with yet. Hopefully we'll have that at some point. But there's no way to check what an API was called with unless you build it yourself. And how do you build it? You do a mock. So let's do a setCookie mock with name, value, options. So actually we'll just use ES6 here as well. So where do we get the name, value, and options? Well, let's check out what setCookie digests. So name, value, and options are what it actually takes as parameters. We could use encode here, but we're not using that, or we're not testing that, so we can ignore that. So name, value, and options. So now whenever the setCookie API is called, it's passed the name, value, and options from the template itself. So setCookie here is called with name, value, and options. So now we can actually test if value is not true, because that's what we expect. We need to fail the test. And how do we fail the test? Well, there's actually an API for that. There's an API called fail. So fail API can be used to actually fail the test. So let's say cookie set with invalid value. If the value is true, then the setCookie API just has been called. It has been called, so the test will be a success. So let's check it out. So the test was a success. Now, just to show an example, let's change single percent to 49, just to illustrate the example. So this time the random number generated is more than the distribution. So this time the value should be false because it's not part of the distribution. So let's see how the fail thing works. So the test was failed and it says cookie set with invalid value. So this is how the tag template test works when you're mocking an API and checking the value. You're expecting these APIs to be called with predictable values. And this mock fail pattern is great when you want to check whether an API was called with a predictable value. So this test should now be a success because when the setCookie is called, it's called with the value true, because the single percent falls within the random number falls within the single percent we established in the setup object. So let's do the next test. Set single cookie to false when outside distribution, right? Let's paste the code here, and now we just change the generate random to 51. So 51 is larger than what we have in the setup mock, which is 50. So the user should not be in the distribution, and the cookie should return false. So this time we check if value does not equal false, then the test will fail. So let's see what happens. And the test is a success. So now just to reiterate, we've now tested, we are now testing in coverage. This if check is positive, so we go on to here. We skip the comment. It's a single distribution. So we run here, we run the setCookie, and now we've tested both the true and the false values in the ternary. So ternary is like an if statement as well. It has two different branches. It has true and false. If you only test one of them, then this line would not have 100% coverage. And the next thing we need to test is make sure that the domain, the cookie values, the options of the cookie values are predictable. So let's create a test for that. Set single cookie with correct options. And let's just copy this test. And this time we can have this this fail here. It's not actually, let's not have that. It's just confusing. So here we check the options. So if options.domain isn't auto, fail, invalid cookie domain. Let's run the test. And the test was a success because the domain passed in the options object had the cookie domain value, which was auto. Then we'll also check the MaxAge value. So MaxAge in the options object is cookie MaxAge, which is what's added to the cookie expires times 24 times 60 times 60. So this is the days. Cookie expires takes a value in days, so 365 days, and this 24 times 60 times 60 turns it into seconds. So what we need to do is check if options MaxAge isn't 365 times 24 times 60 times 60. Fail, invalid, MaxAge. So let's see what happens when we run this test now. It's a success. So now instead of hard coding these values, a much easier way to do it is to use your mock object. So single mock times dot cookie domain and single mock dot cookie expires times 24 times 60 times 60. So this way you can change the parameters of the test by changing the mock object values without having to change the test itself. And otherwise, the test can run as it is. So now we've tested everything from up here all the way past the if block, and then we've tested the entire single distribution if block. It only had a single branch, so checking with whether it was set with a true or false value. And then we get to the multi-tests. So let's just copy the base. We'll need to make some modifications to it though. So let's do set MultiCookie to variation 1 when equal to 33. Wow, that's horrible stuff. So get cookie values has to be empty so that the cookie doesn't exist. Generate random has to be 33 because we want to test variation 1, which has a probability of 33%. So values of 1 to 33 would return variation 1. We want set cookie to be called with variation 1 because that's what the cookie would be set. It would be set with the value set as the group value. We run the code with multimock. Generate random is called. Get cookie values is called. Set cookie, let's check it out. Set cookie is called because the random number is below the accumulated probability. And make integer is called. So it's up here. So we can actually change that to was called. So let's see what happens when we run this test. It's a success. So then the next test to write, we need to test the second distribution we added. It's not necessary because our code coverage has already been checked, but we wanted to make sure that this iterator adds those probabilities to the accumulator would be always have a predictable end result. So we want to just test, just for flavor, we want to test multiple variations. So set MultiCookie to variation 2 when equal to 34. Let's push it to its limits. So it's not always about getting 100% coverage. You might actually want to test different inputs as well, even if the coverage itself doesn't change, because this makes it easier to make sure that you can add multiple new branches in the future and the test would still pass successfully. So let's generate a random of 34 Now if the value is not variation 2, then the cookie would be set with an invalid value. And otherwise everything is the same. Let's see what happens. So here we go, it was a success. Then the next test would be do not set MultiCookie if higher than 66, because if it's 67 or higher, then the cookie would not be set at all. So let's see how we would establish this. Get cookie values would be empty, generate random is 67. Set cookie would now fail if it's called at all, because we don't want the cookie to be set. Set cookie was called. MultiMock is run, generate random is called, get cookie values is called, set cookie is not called, make integer is called. So you don't necessarily need this, because this would be failed as well if was not called would fail. But it's a nice way just to add some readability to the test and to get some edge cases out of the way that might arise otherwise. So here you can see that it works nicely. And finally, let's make sure that the MultiCookie is set with the correct parameters. So let's copy this test, for example. MultiCookie set with correct options. So this time we don't care about the value, but we do care about the options. So let's see options. Cookie name. Sorry, let's do options.domain. MultiMock.cookie name. Fail invalid. Multi.cookie domain, invalid cookie domain. If options.domain, options MaxAge is in multimock.cookie expires times 24 times 60 times 60, fail invalid expiration, cookie expiration. And then let's make sure that everything else is okay, and then let's run the test. And it's a success. So then we can run all the tests, and everything is successful. So now we should have, again, 100% coverage. We're testing all the APIs, we're mocking some of them, we're testing all the possible user inputs. If the cookie has not been set, we run the first test, do nothing if cookie exists. So in this case, the cookie is not set, and only the GTM on success is called at the end. If the cookie is set and it's a single distribution, we check whether the value was true if it's within the distribution and false otherwise. So it's the tests set single cookie to true when in distribution, and set single cookie to false when outside distribution. And then we test whether the cookie is set with the correct options. So options taken from the input. So we'll just check that as well. Then we go to the multi-distribution. If the random number is smaller or equal to the first group threshold, which is 33, then the cookie value is set to variation 1. And if the cookie value is set to variation 2, so if the random number is equal to 34, which is within the variation 2, then the MultiCookie is set to variation 2. And if the cookie value is higher than any of the distributions specified in the options, then no cookie should be set. And finally, we need to make sure that the cookie is set with the correct options. So now we've written a test for a variable template, which is a very simple affair because you can use the assert that API to make sure that the variable result is predictable. And now we've also built tests for the tag template, which is a bit more complicated because we're mocking APIs. We are building our own custom assertions with the fail command. We're asserting that APIs were called to get coverage. And finally, we make sure that the tag finishes successfully. So in this case, getting full coverage is a bit more difficult because you're not actually checking for a return value. And with tags, the concept of unit tests is a bit more complicated because they don't guarantee that the template actually works. They just guarantee that your code works. They don't do the API calls, they don't send the pixels, they don't do any of that. You're mocking those values. So this can be a bit counterintuitive if you're new to testing, is that why do tests at all if all you do is mock values? Well, the purpose of the test is to make sure that the functions and methods you build in your code work as intended, because those are the first things that fail and the first things that break an environment when you change your template code. You have no control over what third-party APIs or pixels do, but of course you can add tests for those as well to make sure that and write code that captures all the different permutations of those API calls. But with unit testing, you're specifically testing line by line your code and making sure that your changes to the templates do not break anything. So I really encourage you to write tests for your templates, because when you create new updates to your templates, you want those tests to pass so that users who are using your template already would not get a broken environment as an exchange for your latest updates. So this is all about tests. I hope this has been useful. And be sure to check out all the resources that I'm sharing in the video notes, and just contact me if there's something unclear about any of the stuff that I've talked about here.